Hey, everybody. Welcome to eCHO 14. This week, we have a special guest, Mr. Antonio Ojea. He'll be on with us here in just a minute. But first, I wanted to say hello and see how everybody's doing. We got Mr. Alex Barnes checking in. Good to see you, Mr. Alex. I'm actually going to be working on, I'm going to be a guest on the Atlanta Kubernetes meetup here in, I think, this month. And so Alex was actually just asking me to send information about what I wanted to talk about, and I haven't done that yet. So I've not forgotten, Alex. I'm going to do it today. But yeah, that'll be a fun one. If you haven't attended the Atlanta Kubernetes meetup, definitely check it out. It's a great virtual one. Good to see you, Khalid. No, good to see you. Everybody checking in. Awesome to see so many awesome friends checking in here. Good to see you all. All right. Well, let's take a look at what we have to talk about in this week's notes. If you go to hackmd.io/@echo-live, you're going to see all the notes that we've published, and you can actually you can see what we've put up there, and participate and that sort of stuff from that perspective. So definitely, if you have anything you want to put up there, or if you want to just follow links that we refer to in the show, or if you want to see what the reference material for the show is, you can definitely just come here and see what they are. So like I said, if you go to eCHO Live, you'll be able to see the link. Or if you want to go to a more direct link, I put a link in the chat. Notes for this week are located at hackmd.io/@echolive/14. Hello. Gosh, it must be a crazy hour in India, but good to see you. I'm glad you're here. I'm looking forward to being there as well. That'll be a fun talk. All right. So this week's headlines: detecting kernel hooking using eBPF. I thought from a security perspective, this was pretty interesting. And so if you're interested in this kind of stuff, this might be pretty interesting. So a common technique for Linux kernel rootkits is to overwrite function addresses in the syscall table. And so if you think about it, like file open might do something different if it has been, if that memory location has been overwritten by some other function, right? And so apparently with eBPF, we can detect this. We can determine that perhaps has changed according to this demonstration. I haven't worked through this demonstration, but it's a pretty fascinating idea. One of the coolest, lesser used features of eBPF is the ability to record stack traces of a function call, showing what functions were called, both user space and in the kernel. Like, this is a kind of a interesting preview of some functionality that we're working on at Isovalent, interestingly enough. You would need to have a debug kernel. You need to have like the BTF files and stuff, or the proc call sims, what they call them, so you can actually understand what's happening. But if you're interested in that kind of a show or what's happening with that, that's pretty cool. The link is there in the notes. The next thing I think that's pretty interesting is Facebook enforcing encryption at scale. So let's see what's happening here. Implementing transit encryption enforcement policy at Facebook scale requires careful planning. They built an SSL wall. And with eBPF, since we wanted to inspect every connection without needing any changes at the application layer, which is a problem that pretty much every Kubernetes user has, we needed to do some work in the kernel context. We use eBPF extensively, and it provides all capabilities needed for SSL wall to achieve its goals. So basically, they are capturing every connection and encrypting. Pretty slick. Transparent TLS and the long tail. I mean, if you think about it, like the way that the way I've seen this done, and the way that we do it actually within Isovalent for the Cilium product is by leveraging a more transparent encryption model lower in the stack, right? And so instead of enforcing that there be an encryption model for every individual application, this proxy model in this particular picture is that we might ensure that every node in the cluster is a part of a WireGuard mesh or part of an IPsec mesh. And then we just do transparent encryption before the packet hits the wire, ensuring that all things are encrypted back and forth between pods. But it's an interesting play. I think this is a little bit different on architecture from that. I'd be kind of curious about digging a little bit further in. But another really great article. Shout out to Quentin, who collects all of these articles for us. I really do appreciate that. Next one up that I thought was pretty interesting was having the TES Edge nodes memory usage with an eBPF-based memory profiler. And I'm seeing more and more work in this space. And I definitely have a few friends who are working on this sort of material. But a way to use eBPF to do more kind of generic profiling on memory and CPU and other resources. So they talk through how to locate memory leaks, memory usage tracing. Once we know the PID, the BPF module intercepts every memory allocation that happens in the context of the PID. So, and that word context is like the super killer when it comes to BPF. Like that's, if there's one thing that eBPF actually really enables us to do more than anything else, it's actually that context piece of it, right? Being able to really understand for a given process what's happening. But pretty cool. I mean, I think that would actually be kind of an interesting generic implementation to make it so that any process you would have some view into, like whether you had that memory allocation going up or down. Especially because pods have so many, may have more than one process in it. Noel says, that's cool. In CI tests can be run against a PR to see if the code, yeah, that's true. Yep. Yeah, if you had the hooks and stuff, you'd be able to actually see if the memory allocation for a given process or for that particular binary had increased or decreased. Yeah, that would be neat. So today we have Antonio. I'm going to bring him on screen here. Welcome to the show, Antonio.
Hi, Daffy. Thanks for having me.
I'm glad you're here. Antonio is one of those people that has two names, one on Twitter, one on GitHub. So it's Hugo on Twitter and on GitHub, but he's Ojea. I met Antonio through the Kind community, so I spent a lot of time working and helping people with Kind. And Antonio wrote like the network implementation for Kind, and also is just generally super helpful there. So welcome. I'm really glad you're here.
Thanks for having me. You are as helpful as me in Kind, or if not more.
Thanks.
We have a lot of fun there.
Yeah, I definitely enjoy it. I'm looking forward to like maybe getting to hang out in person again at some point. But I think we're still a ways away from that. But gosh, I can dream. It'll happen again.
Yeah.
But it's still a ways away. So Netcat is a project that we were going to talk about, and this is one of the things that I really want to kind of do a little bit more on this show. Is I want to find people who are solving real problems with eBPF and bring them on the show to talk about like what they're doing and how they and what the problem was that they solved and make that a part of kind of the recurring theme of the eCHO live stream. So if you're listening and you're doing something with eBPF or anything else like that, just reach out to me on Twitter or send me an email to let me know, and I'd be happy to invite you on and talk to you about like what you're doing and what your journey was. So you want to talk a little bit about Netcat?
Yeah, well, so the motivation is, as you know, in Kubernetes we have a lot of IP tables and IP table problems. So you spend a lot of time. Yeah, that meme is that's the reality.
I love it.
You have a lot.
I see a small cluster.
That's guaranteed. You have a lot of IP tables. And the problem is that how do you debug everything? And if you have Kind that also has another layer of virtualization, you still have more IP tables. So I needed something that to be able to say, well, is IP tables or is not IP tables? What the hell is blocking or changing my packets? And that's the reason why I created Netcat. So everybody that is in networking, I think that they have used network at least once. It's a simple tool that basically is a pipe between the command line and the network. But this version is implemented using raw sockets. So with raw sockets, what you do is you get a copy of the packet before the packet reaches IP tables in the kernel. Just simplify it. So it's the same as TCP dump. Imagine that you get a TCP dump, and you, without those packets, what I did is to hook that to a user space TCP IP stack. That is the gvisor TCP IP stack. But the problem is, okay, you have the packets from the network, you have a clone of the packets, but the problem is that you are still receiving a lot of packets from the network for your user space stack, and the host is still receiving the packets. So you need to filter that. And for that is when eBPF was very helpful, because with just I don't remember the number of lines, but I think that is 100, 200 lines. You can create a simple eBPF program that filters that traffic. And the good thing is that right now the ecosystem is growing, and you have tooling, so this eBPF filter can be modified directly from the Golang code. So with that, I was able to create the pipe with the sockets, send the packets to the user space stack, and with Golang, just do the copy from the terminal to the network socket. So you have a netcat that is able to bypass IP tables and everything that is, beyond the point of the raw socket.
Nice. I like this idea, basically, of grabbing before the TCP set. You actually had another diagram in here. I don't know if
Yes.
there went. Yeah.
That
lays out kind of like how this was working, or the theory of operation for how this is happening. I think this actually does a great job of explaining it. When I first read the project, one of the questions I had was the gvisor piece. I was like, wait, are you, because there's already a network NS. So like, why are you creating because in my mind, I was thinking that the gvisor TCP IP stack, when I read it, I was like, how are you going to inject that in there? But it makes more sense the way you're using it. Just using it as a user space mechanism to effectively manipulate packets into a stream so that you can actually
right.
Yeah.
It makes the hard work of giving you a socket output, so you don't have to deal with the packets or all the low-level stuff. The TCP IP is done by the gvisor, and it's easy to plug in.
Yep, makes sense. Yeah, the other thing I noticed when I was playing with the project before I invited you over, which I thought was pretty neat, was that you wrote a bunch of tests for it, and I really like how the tests were written. I wanted to kind of go through some of them and show how that was done, right? So you actually use a BATS. I don't know if people have heard of BATS. I'm just going to do this. BATS is like a bash testing framework, and it's totally like if you're just looking for something super simple that can give you an output about whether things are working. It has a decent mechanism for doing this sort of stuff. Like, so if you're going to test a command line tool or something like that, BATS actually gets the job done pretty efficiently. And it can be extended to do some interesting tests, like you can do assertions, you can do that sort of stuff. But the way this was set up, I thought was pretty neat. So you have, for every test in your test suite, the setup will be run and the teardown will be run. So when the setup, what Antonio did was created 2 network namespaces directly against the Linux kernel, and he gave each of those 2 network namespaces a veth that are part of a pair. So now effectively what we've done is any changes, any testing we're going to do are going to happen isolated within a network namespace. It's not going to manipulate anything on the host, which I thought was definitely, I was like, I don't know if I want to run tests. But then when I looked at what you were doing, I was like, all right, okay, I can get behind it.
Test has to be clean. I mean, when you spend a lot of time debugging tests, this is the most important thing. They have to be clean.
Exactly. And so effectively, this just basically throws an IP address and a loopback address, or a loopback interface and an Ethernet interface into each of those 2 network namespaces, gives them addressing so that they can intercommunicate, and then proves that connectivity works between the 2. And so this whole setup, because it's BATS, this was the other thing I really dug about it. I can copy all of this down to here. Yank. Paste it into my terminal. And There are my north and south network namespaces. I can see connectivity works between the two of them. We have our test environment set up. And nowhere in my, on the outside is that 1.1.1 address. That is totally isolated within just those two network namespaces. So it's just simple plumbing connectivity back and forth between two network namespaces, completely isolated under their own. And the benefit of this is also that you can do kind of interesting tests, like you could do tests like these here. The teardown is basically just deleting the two network namespaces and then killing any existing processes that remain within them. So IPNet also has the ability to identify those PIDs that are associated with that network namespace, and this is basically just doing a kill on anything that comes up that is still running inside of those. So your teardown just really cleaned it up. So then the fun part, like that gets more interesting, is like doing just a TCP connect back and forth between the application that we're testing, netcat, right? This is the binary that is the output of Antonio's test, and NC, just using the standard netcat, right? So you're listening with the standard netcat, dumping that to a file, and then sending some context, or like the test short log, which is just a short amount of text across netcat to that destination, and then proving that these two things are equal. And then that passes your test. It's like such a simple testing mechanism that I thought was actually really cool. And then when you get into the more advanced testing, like you actually have proven connectivity. Now we have, because this network namespace is isolated from your host, again, it's still running inside of a network namespace, you could just do something like drop all traffic to that destination and expect that it to work, right? So in this IP tables line, we're basically saying in the output chain, for the destination 1.1.1.2, drop that traffic. Doesn't matter what kind of traffic it is, just drop it, right? And then we do a test to prove that this exits 1.
Yeah, that's very important. Yeah.
You know, and then the next bit is basically just doing the test, the same connectivity test again, right? Listing in one of the network namespaces and checking in the other network namespaces. So this is actually, yeah, I mean, to Noel's point, this is actually a really great crash course. Like if you're just going through this process and you go through these commands one at a time, this is a great crash course into what network namespaces are. And network namespaces are just one of the many important namespaces that comprise a pod in Kubernetes, right? So if you create a pod in Kube, then that pod is going to be allocated a network namespace. And all of the containers within that pod are going to share that very same network namespace. And so I thought this was a ingenious way of doing testing. I really thought this was pretty cool.
Yeah.
You know, doing the, go ahead. What were you going to say?
No, the thing is, it's important when you are, that's failing because you have the namespaces exactly. already created, so it's not able to create that. It might exist. So it's important to have tests because otherwise, when you are developing, you can regress. And that this way, I mean, people can. I'm happy to accept PRs or something because I know that we are going to have at least the same functionality working.
Yeah, definitely.
And as you say, this is pretty simple to add one test. It's 5 minutes to add. I mean, you can overcomplicate whatever you want, but the simple test to test that it works, the connection or the listening, is as you say, is pure hash, namespaces, and IP tables.
Keeps it as simple as it can possibly be. I agree with that. Like I thought that was one of the things I really dug about the way this was laid out, was that it's a super simple test. And unlike some other tests, I mean, like you can still do like a targeted test. So they do allow like a filter or a regex where you can just rerun the same test until you get a pass, right? But at the same time, you also have the ability to, because it's just bash, right? Like it's very easy for you to map what's happening in the test mentally to how you would do it manually, so you can like dig into the test and troubleshoot it. Like one of the problems that I ran into with the original test was that I was using a netcat from a GNU netcat, and so it requires when you create a listening NC, it expects that you have defined a port, -P port. And the netcat that Antonio was using was the the one from Nmap, which does not have that requirement. And so I was like, I can see it's listening, but it's not listening on the right port. And it took me, unfortunately, because it's all just bash, I could very easily determine what happened,
Yeah, so many netcats. There are many.
Yeah.
That's why I didn't want to add a new one. But I mean, it was surprising to me that there wasn't any project, because I'm a very lazy person. If already knew there was something working like that, I wouldn't build the tool. But I'm happy because I was able to be in contact with eBPF. That was something that I always wanted to try.
There you go. So next up, I guess we're going to play with the demo, and this is a diagram of the demonstration of what's happening. So this will be leveraging a kind cluster, like we talked about before. And this is a great time to jump into the notes if you haven't already. What we're going to be doing is basically walking through this demonstration that's documented here in the notes. So if you want to walk through it with us and you have the ability to stand up a kind cluster, give it a shot. Like we can ask questions. You can ask questions in the chat, and we can help you inside of this space. But like you're welcome to come kind of walk through it with us and see how this goes. So, do you want to drive this, or do you want me to drive this, Antonio? I can't remember which one we agreed on.
I mean, I already proved. If you want to try it out, because
all right, let's do it. Yeah,
it would be, I don't know, more. So people can see that it works. It's not recorded by me.
All right. I don't know. I'm going to kick the instructions over to my left side, and we'll be walking through the terminal stuff that I'm doing on this side. So.
So the thing is, I already have a cluster running, so maybe we can save that time if you want.
Go for it. Make dear, I'm going to call this echo. Oh, you're just doing it all in one command. That's cool.
Yeah.
Okay.
Whoa, that's starting fast in your machine. It takes more time in my.
I'm actually really happy with this machine so far. It's been pretty fast in general. When I was shopping for a new machine, I decided to try an AMD chip, and so I ended up. Whoop, is that too big? There we go. I ended up getting like one of the Ryzen laptops. So it's the T14S, I think it is. With 16 cores and 32 gig RAM. And I found it on eBay for like a song. It was really inexpensive, and so I was like, this is probably the least expensive laptop that a company has bought for me, and at the same time, probably the most powerful that a company. It's like, computers. It's so weird.
Yeah, definitely, because for me the cluster to bring up takes 1 minute or more, and yours is already running. Okay, so let me try to explain a bit the demo. The demo is one of the reasons why I created Netcat. In SIG Network we have to SIG Network in Kubernetes. We kind of own the load balancers API. And the problem is that for testing the load balancers, we need to rely on a cloud provider. That makes the test more flaky and slow. So I wanted to change that during this new release, and for that I created the plan is to create a fake load balancer controller. The other thing that you need to test the load balancer is supposed to have external traffic and direct to the cluster. But when you are testing in Kine or in some Kubernetes environment, the E2E binary, the one that launches the test run outside of the cluster and only have connectivity to the API server. So the common trick is to use a pod inside the cluster. However, the problem of using a pod inside the cluster with load balancers is that all the traffic of the pod that is going to emulate the external traffic is going to go through proxy, and instead of detecting the traffic as external, it's going to detect as internal. As a result, we cannot test load balancer mocking the load balancer. But however, with Netcat we can, because Netcat, and this is the thing that we are going to demo, Netcat traffic is not going to be affected by IP tables, and the cluster is going to think that this traffic is coming from an external host. So we can test the features in 1 minute, and current tests, I think that we're taking 20 to 25 minutes to run. So the improvement is a lot.
I don't know.
So this is a very. I have some network controllers. So this is a simple controller that what is doing is watching the services. When it finds a load balancer service, it just assigns one IP. That is basically what the cloud provider load balancer is doing. Okay. The thing is that we need to do the data path by hand. So we need to install the routes in the node. It's very similar to what MetalLB does.
Makes sense. Shall we take a look at it just real quick?
Yeah, okay. So the important, that's you are not going to see anything there. You need to go to the library that is in the package folder. So
this one?
Yeah.
Package load balancer?
Right. So that's the all the Kubernetes controllers have the same scaffolding. So, you have a controller, you have the handlers, you have the reconciliation loop. If you go down, you see that the controller has the service lister, the queue, and it has an IP allocator. Those three fields go up.
We zoom in a little bit.
Okay. Yeah, you see one header, one IP allocator, and one service tracker. So that's the thing that tracks the IP on the services. And when a service,
I was like, only you would write that. That's only a thing that you would write.
There is a lot of controversy with dual stack and load balances. I don't want to bring that up. I don't want people to see that.
Exactly. So on service add, update, or delete, these are the things we're watching for on the informer side. We're doing a rate limited queue, which is pretty interesting.
Yeah, basically what the handlers do is just they get the service name and namespace and they put in a queue. And the queue they duplicate. So you guarantee that you are not processing the same service twice. Yep. Also you can batch.
So then you have our handle error.
Right.
Namespace key, retrying, all of that good stuff.
Yeah, and this is the part. This is the whole logic of the controller. So when you have the key, you go to the informer cache and you say, is the service there or not? If the service is not there, I mean, you just need to delete. You know that the service has gone. It's like you need to clean the state.
Yep, you release the IPs when you have them, if they have it, and if they don't already have it, then we have to set one. We can reconcile through. And then you have something doing IPAM probably inside here, huh?
You're going to check the code. It's very funny. I mean, yeah.
No free IPs.
Yeah, it's just look in the range of IPs and start to is the Kubernetes API server has a similar algorithm. It just start in a random IP and start to look sequentially until it finds a free one.
Whether it doesn't ping. Yeah. Okay. All right. Cool. Oh, we got that built. Load balancer. So it was actually command load balancer.
Yeah.
And
You
we
need
have
to
that now.
pass the qconfig file.
So I should have the keep config file. Oh, I have to pass it in the command line. Load balancer dash config.
And you need to specify that's the range that is going to be used to allocate IPs to the.
All right. So we'll put that guy up here in the corner. Zoom him down a little bit. We can kind of see the text that's happening.
Right. Now, when you create the service, we are going to see how the service IP is allocated there. You see?
Yep. Okay, SVC.
The good thing of the random library in Golang is that always assign the same IP. I don't know why. Why it's so random, you know? It's always the 15. So that service that you created is a service that has external traffic policy to local. What does it mean? That it only going to forward the traffic to the pod if the traffic arrives in the node that has a pod on that service. Why is this? Because this way you are able to preserve the source IP.
Oh, wow. My text is very small. I just realized.
Yeah, I think that is one.
So what I'm doing is I'm looking at the YAML of the manifest that was created, and this is the external traffic policy piece that Antonio is talking about. If you haven't looked at Antonio, if you haven't looked at external traffic policy, it's definitely worth knowing a bit about, because to Antonio's point, being able to determine whether you are going to terminate a traffic on a node where a service exists or not is an important step in like maintaining that that header information, right? Like if you wanted to know what the source IP was that made the request, you want to also know it. The other catch to this in Kubernetes networking is that if you don't have it set in this way, what happens is that you can direct traffic to any node in the cluster, whether it's hosting a service or not. And if you land on a node where that service is not present, then the node will kick it over to another node where that service is present. And that means that you increment another hop. And so and in that incrementing another hop, that's actually where you lose that source context. You no longer have it because now the source is that other node, right? It's no longer that original source. And so the tricky, there's lots of other tricky pieces about this, right? Like in incrementing that hop, you might also be incrementing more time for the connection. So if you're trying to actually do like golden metrics for this particular type of connection, you're going to see some pretty interesting things when you're implementing this sort of stuff, because you're going to see some connections just take significantly longer than other connections for some reason. And it might take you a while to kind of get to why that's happening.
Yeah, a lot of funny things happen when you start to double and add things. Oh, well.
Yeah, so let's actually, since we're in that local mode, right, if I do route.
Yeah, that's the by hand load balancer that we're. So you need to find out the node where the pod is running. Actually, there is an interesting feature now regarding this external traffic policy that Andrew Saikin just added. That the problem was that when you were targeting the nodes, if the pod was still alive but was terminating, the traffic was dropped. But now it has a new feature that it's like a graceful shutdown. It's called endpoint slice termination, graceful termination, or something like that. I mean, for people with hard requirements for availability, it's going to be a nice feature.
Huh. Where is that? Where is that piece of it? Where is the graceful termination piece fitting in? Is that in the pod, or is that a part of the service definition now?
In the endpoint slice definition.
Oh, in the endpoint slice. Wow.
Yeah, you are going to have 3 states now. You have ready, you have terminating, and you have well, I can't remember now. We have 3 states, but I don't know why.
So in conditions, I guess when you go to condition ready false, that's when you become
Okay.
that.
Yeah, endpoint slice termination. Let me try to Google the cap.
Yeah, I mean, I'm very interested in that one. Like that's been a problem for some time. I mean, to reiterate, what's
Right.
happening is that if you find it, throw the link in, and I'll definitely kick over there and we'll take a look because that's a fascinating one.
It was a long-standing request. I tried to find the cap.
Okay. If you want, you could just throw it into the notes when you find it, or you can send it to me in the or you can put it into the link. But yeah, apparently, so to reiterate what's happening there, Antonio calls out another interesting problem in cluster networking, right? Wherein like you have a load balancer, and that load balancer is just going to spray traffic across the different nodes. And the load balancer might have some intelligence, right? So like if we're talking about an AWS load balancer or one of those things, it might have some intelligence wherein it basically does like a port knock on the node itself to see if the node's going to be healthy or not healthy. And this is actually another one of those things that like local the local mode of external traffic policy manages. If you have it set so that it's local, then what happens is that when the load balancer on the outside does a ping on that port for that particular node, if there are no services present on that node, then the port knock will fail. And so the load balancer will intelligently take those nodes out of the list, right? And that's a good thing. But the thing that Antonio is talking about is you have a state where you have maybe some portion of your traffic on 2 nodes, and the load balancer is able to route traffic to those 2 nodes, and everything works just fine. And now you're doing a rolling update, and you have sent a terminate to one of the pods on one of the nodes. The endpoint is still defined, though. And as long as that endpoint is defined, unless there's no way that the load balancer understands that it's no longer a healthy endpoint, right? As long as it's still in IP tables and still listening, or however the load balance or the local connection with that node is implemented, it could be a node port. As long as that thing is still listening, then the load balancer on the outside is still going to send traffic to it until it actually goes away. So what Antonio is talking about is there is a way now, apparently they're kept, to extend this capability so that the endpoint has multiple states, so that the endpoint can be, when it sees that the pod is in a terminating state, I'm assuming here, this part is what I'm not sure of. But when the pod is in a terminating state, I'm guessing, let me actually just open this up over here. This is a neat one. Tracking terminating endpoints in the endpoint slice.
Yeah.
Terminating endpoints are considered not ready, regardless of their actual readiness. Before any work is done on improving how terminating endpoints are handled, there must be a way to track whether an endpoint is terminating without having to watch the associated pods. This KEP proposes a means to track the terminating state of an endpoint via the endpoint slice API. This would enable consumers of the API to make smarter decisions when it comes to handling terminating endpoints. That's pretty cool.
Yeah. Do you assume that you have this application that has a termination graceful period of 1 minute? So you are losing that 1 minute. Right now, you are losing that 1 minute because the load balancer is not going to be able to send it traffic. The endpoint is going
Mhm.
to disappear at the moment that you have the delete timestamp on the pod. That's really cool. I mean, I think
Yeah,
that's one of the
that's
nicest features.
completely agree. That's definitely a problem people have, and I think this is a great solution for it.
And we needed E2E test because we are very strict with the testing, and that's why we are creating Netcat to test this feature too. So this is the truth. I mean, how do you test these Terminator endpoints in a reliable way in a cloud? I mean,
Mhm.
it's impossible. Or you play with 10 minutes timeout that makes the test very slow and flake, or you have a deterministic way to decide when the endpoint is created or not.
Yep. So it looks like I sent my traffic to the wrong node. So I'm going to do IP route del. So what I was just doing on the terminal there, I was actually trying to curl a node where the service is not present, and the connection just hung because there's no service there to terminate it to. So I'm going to send it now to the other node, which is number 4. Oh, wait, no, hold on. So the deployment is on kind worker.
So
Kind worker is
2.
Kind worker is 2. Yeah. Curl 10 111.
It was 15, wasn't it?
Oh yeah, you're right. I don't know what was happening there.
Because my note, I mean, my note is with the 199 that is. So
Boom.
you do / client IP, it returns the IP of the client. / client IP.
Yes.
You see, so it gives you the, and 172.18.0.1 is the IP of the kind bridge. So you Docker network inspect kind, and it can. And you scroll up and you see gateway. Okay, subnet gateway. So that's the original IP.
Yep. And that's happening because I'm actually coming from basically the Linux stack. It's going to use an interface that's closest to the route, right?
Right.
So the source IP address is always going to be whatever the closest to the route is.
We had a lot of fun with that, with the UDP and host network pods.
Yeah, so that works. That's pretty cool.
So
So where are we at? We did this piece. We did the check of preserves host IP. So we definitely see that it is preserving it. And if we kick it to the other node, so let's go ahead and do that.
you need to delete. Okay, it was.
Remember what the IP address of the other host is, though.
I think that is 2, 3, and 4. Just pick one.
It's 4, yeah. Nope.
Yeah.
That works the way we expect it to.
And if you mutate the service now to be external traffic policy cluster, I think that they have the command there. It has to work, and you will see the IP of the node in the.
I was all getting ready to edit it, but I like your patch command.
You see, now it works, but it is getting the source IP of the node of the kind worker too.
Exactly. So, because this is what we were talking about before with this whole traffic policy thing, right? If it's external traffic policy cluster, the curl, my packet is being kind of terminated and sent again from the node that I'm targeting, right? So right now I'm sending this traffic explicitly. I'm sending this traffic to a node where the service is not terminated. The pod is running on a different node. But the node is going to do its best, right? It's going to say, okay, well, it's not here, but I know where it is, so let's just reconnect you over there. But in that process, we've lost the header information. We've lost the source identity for the packet.
Yeah, and that's important. I mean,
Yep.
if you have an application and you want, I don't know, some metrics or to know the whatever thing, you are only going to see the IPs of your node. That's not good.
Exactly.
Okay.
So test the service from within the node without the pod. So let's do that.
Now, do you have to install the Netcat pod or not?
Yeah.
No, but you need to. I have a YAML with the pod, so install Netcat with a pod inside the cluster.
Oh, okay. Well, let's do that. Sorry,
Right, because
we had
this way is portable and you don't need to carry on the binary or install anything. You just use Kubernetes API for everything.
This one?
I should have it here.
I mean, I could just do this. Oh.
Let me share. No, let me give you the link. I think that is in the notes, but I have it in a gist.
Mhm.
So I'm publishing images.
Yeah, I'll be the OpenBSD one. All right, here we go.
So I'm publishing images so you can see. You can use directly Netcat from a pod.
All right. One of the fun things I do in some of these containers for my images that are like this, where I want to use them as a debug command, what I do is I do a multi-stage build and I grab the pause binary from a pause container and make that the command, and it just sits there and pause forever, and then I can connect and do whatever, you know.
I mean, I'm sure that you have a lot of these nice tricks.
It works out well. All right, so this is now running.
It's in the same, checking in which host is running.
Oh yeah, good point.
Okay, so both are in the same.
Yeah.
Okay, but you can do a trick. Just download the YAML file directly and modify the YAML to set the spec dot node name. So the schedule we bypass the scheduler and we tell the pod to be created in the other node.
One of my favorite tricks. But you want them to be on the same node?
No, we have this in the same node, but let's create another one in a different node.
Okay.
Because it's in the same node. I don't know if the traffic is going to hairpin, and I mean, you're putting me in evidence because I don't know if that is going to work. I know that from different nodes it works.
It's currently on 2 different nodes.
Okay, perfect.
Yeah.
Okay, so eCHO and .it netcat ASH. Oh, okay, that's no, it's an Alpine, so you have SH only. I think
okay.
you have a Netcat already. Netcat and the binary. You have both pre-installed.
Okay, so this is for me. It's 15, but that's the only thing I have to change there. So.
So that's the thing is the load balancer now is in local. So from that node, that is not the node where the pod is running, you shouldn't be able to reach the service, right?
Yeah.
That's how, because we changed the service to local, okay? And what is the problem? The problem is that because the traffic is coming from inside the cluster, it's not external traffic; it's internal traffic. then
Yes.
it,
Yep.
then that's the problem. So it's normal that it works. So that's why when we use now the netcat with K, the netcat with raw sockets, the traffic is going to be external and is not going to be able to reach the service.
That makes sense.
Be-
Yeah, because you want to basically prove that it's external traffic.
Right. This and with this you can automate the test, and then we can start. You can run a test for testing external traffic policy in 1 minute, 2 minutes. But the test that we are running right now, it takes 20 minutes because you need to create a load balancer in the cloud provider. That is slow and is not a stable time. So sometimes it takes 1 minute, other 5, and for a test is not very reliable. And this will allow all the SIG network members to test better these features in with kind.
I like it.
I'm practically doing all the networking development in kind. And this was the missing part: is you cannot develop load balancer features in kind. With this, we are going to be able to do it.
That's very cool. That's awesome. How are we doing with comments? How's everybody doing?
Yeah,
that is going to be pretty amazing.
Uh,
So Noel's giving us some positive feedback, telling us it's going to be amazing. I agree. This is actually a pretty good solution. I like both that, the terminating state of the endpoint slice. That's something I learned this time. And then also I like the solution, like using Netcat for that, to actually do that piece of it.
you can do more crazy things. So you can open a stealth server, but I mean, I let the people with more hacking skills to figure it out. It's a good
Mhm.
exercise.
It is a fun
Because,
one.
yeah.
Yeah. And if you want to play with that more, like hands-on, like I was saying before, the tests that are in here. You decide to kind of explore how these things, how that connectivity works. Definitely check out the tests, because the tests will show you just exactly how you can establish connectivity between two things, even with IV tables in the way. So that's a pretty reasonable way to go about it. One other thing I wanted to try with your stuff, which I thought was pretty interesting, was, so we've done this piece. So we got that. Ascending. Sending. So you had said in here that the connection, that part of the output is the ability to listen to like debug, which I thought was pretty interesting. So if we go into Docker, let's see. It'll you have Netcat as a deployment already, and it's listening.
No, we created the Netcat as a pod without the project.
Yeah. It could be. This already has netcat in it. I'm going to copy that. And then the command that you have defined. Perfect.
It's
Because what I wanted to see, I think it's possible to do this. I wanted to see the debug part of it.
with the debug you have a sniffer. So when you add the debug flag to the netcat command, you get the traffic. It dumps the traffic as a TCP dump, but the traffic only that matches the connection that you specify in the netcat options.
Yeah. I'll pull the spec up here.
So I think that you can use the don't.war API to get the node IP and to populate the fields of the command.
Again. D6 down. Spec. Paste. Okay. Easy surgery. Six. Shit. But it is spec, right?
Right. Just
all right. I just want to set this up so it's listening on bash, and then I'll start the listener myself, and then we'll expose the deployment, and then we'll be able to see what that looks like. So kubectl apply -f deploy. Oh, tabs versus spaces. Oh.
Okay, you have two kinds.
F1 deployment.
Right.
Oh, I have a name.
The container. And here you go.
That's all right.
No, it's not in the path. You need to specify the path. And you need an IP that actually exists.
Oh, whoops! I forgot about that.
You don't have.
Yeah, kubectl edit deployment. Actually, it's just been the deploy. Privilege true somewhere in here. Let's actually just look at an example because there are certain things I'm not generally going to remember. Good old, hello in India.
Well, it has to be late there.
Yeah. I was just thinking as well. I was like, my goodness. You're here. I appreciate that you're here, but wow. So you went with HostNet. I think I'm going to leave it in the overlay because I want to use it as kind of a behind a load balancer or whatever. But I guess I could do it with HostNet. And then privileged equals true. Where is the privileged equals true?
Yeah, there. You need host network because the IP table rules that you are bypassing are the host IP table rules. If you run in a pod, you are not able to bypass the IP table rules from the host. You are isolated in your own network namespace.
That does make sense. I think, yeah, I mean, we could do it as a HostNet. I was thinking the test I was trying to run here, I wanted to see the debug command. I've been doing this a long way for no particularly good reason, but
no, but that's cool. I mean, I'm going to steal your YAML once we finish. So.
Work, is that right?
I always it's in the spec. No, the host network is in the spec or is in the container. Oh, let me check it out.
It is.
It's in the spec.
Host network true.
It's in the spec. It's not inside the container. So the security context is for the container, and the host network is for the spec.
Weirdly, it's in both. That's one of the things that drives me nuts about security context, is it actually resides in both places.
Right, but this changed recently too.
That's true.
Now you can filter by capability, or I don't remember now. This has improved in the latest version too. I didn't have time to check that out.
Apply. Nope.
For security.
Someday I'll get those tabs right, you know.
Mm-hmm.
All right. Oh, I just realized we hit the top of our hour. So I want to, but let's just get a little bit further. Let's see if we can get this thing working. Exec TI.
Time flies always that I joined you.
Right. Always.
Right. I don't know how do you do it.
8.
No, because okay. Pod's not found. Why is not finding the pod?
I ran to the wrong one. My bad.
Okay. Okay. Here you go.
IP. Nope, I'm still in the overlay. No, I'm not.
No, you're good. The thing is, you need to.
Then we have Netcat.
You need to specify the path. I need to.
-T -L 80.
And now send traffic, because unless you send traffic, you're not going to see anything.
Okay, so then we can do kubectl expose. Oh.
Yeah, you can send traffic directly from your host.
See, hello. Yes. So that is, what host is it on? Wide. It is on kind worker. Get nodes dash o wide. And worker is 172.18, so I can do echo, hello, and see. And then the service port.
The service port is the 80. You
No.
see, you are receiving ARPs. check your upper tab.
Oh, that is cool. SVC. Expose deployment netcat. And I want to set this as type equals node port. Okay. Yeah. And 1, 2. And, oh,
No, that's not gonna work because it is going through IP table. I mean, the node port is going to get the packet and it's going to DNAT. So I don't know if. Well,
it
now
should allow
that
it.
now it's an interesting question. I need to try that out because the packet flow is as follows. The packet reaches the node port on the node. Then it's DNAT to the node port to the service port, and the service port to the container port. So I
Yep.
think that it never gets out of the kernel. So where is the traffic sent? I mean, I think that it's not going to work. So you can do the curl directly to the IP of the node and the port. Which port is listening the netcat?
That's what I'm saying. That's what I'm.
Instead of the node port, just reach directly the netcat. No, with curl.
I know. But so this one is on 1802.
Right.
Curl.
And
132. Oh, that's you're right. That's because it's part of host path. Now it's part of the Okay, that makes more sense now.
is that the okay? You see it.
Yep. It
And
works.
that's an stealth server because nobody. I mean, you can log in now in the host and you cannot see anything in that port listening. And you can add an IP. You can add an IP table rule in the host, and it's not going to drop this connection.
Yeah, because it'll bypass the whole IP table stack.
Right. So this is a backdoor. Well, you have to be root and or this capabilities is I don't remember. I wrote the capability that you need is I think that is net pro. I mean, you should. If you have a
Yeah.
cluster, you need to be careful about security and not allow pods to get this privilege because it's easy to make bad things. And there's a lot of bad people out there.
Yep. That's fun stuff. All right. Well, I think that's going to bring us to the close of our show. So I want to say thank you so much for taking the time to come be a part of it. I really enjoyed hanging out with you, as always. And I learned a bunch of stuff, and I hope you got something out of it, and you as well as the audience. So thanks, everybody.
Thanks for having me. I really enjoyed it.
Yep. Have a great weekend, my friend. I'll see you soon.
Bye.
Bye, everybody. Okay. I have to do the closing thing. 1 second. Let me do one more thing. I know there's a place here in the... Still learning the... All right, my friends. See you all next time. I'll be back in about 2 weeks.
See ya.